This seminar will be recorded. And hi everyone, this is Yue, and we should have a good time during the summer. And today we are very pleased to introduce Dr. Daisy to talk about her research on modeling and forecasting passenger travel. And Dr. Daisy is a transport modeler at the Ministry of Transportation of Ontario, where she leads the land use modeling files and works on two state-of-practice transportation demand models, including Greater Golden Foreshore model and Regional Economic Simulator of Ontario, which we'll be talking about today, to support the regional transportation master plan projects and the corridor planning studies. She also teaches transportation courses at the University of Toronto as a sessional lecturer. She received her bachelor degree and master degrees from the Bangladesh University of Engineering and Technology in 2011 and 2013, and her PhD degree from the Dalhousie University in 2018. Dr. Naznin's PhD research focused on the development of a state-of-art activity-based model, scheduler for activities, locations, and travel model, a tool which has the ability to predict and construct the 24-hour activity travel patterns and the corresponding travel link with activity accomplished by individuals and could be utilized in various short-term and long-term transportation planning needs, such as bike lane implementation, transport emission estimation, transit-oriented development, transportation equity, disruptive emerging mode choice decisions, etc. And let's please welcome Dr. Daisy. And please give to Dr. Daisy. Thank you.
Awesome. Thank you so much, Siri, for such a elaborated introduction. So as you mentioned, currently at the Ministry of Ontario Transportation Ministry, I have been working on two state-of-art activity-based and disaggregated model. One is in the regional scale, which is the GGHM, as you mentioned, Greater Golden Horseshoe model. And the other one is for the province-wide, similar to what you call in US, a statewide model. So which one is the TRESO? So it's the regional scale and the province, or compared to the provincial scale here in Canada. So today I will talk about a little bit about this statewide model or province-wide model that is first of its kind in Canada, and what are the design consideration that has been made when we were building this model, and then going forward with the model details, and what are the system overview of this model. And then I will deep dive into one of the component of this model, which is the travel outside the metropolitan areas, or the TOMA model. And then I will also talk about the components of TOMA model and how we can apply this TRESO or TOMA model, and what are the current applications that basically we are having here in the ministry. So in any kind of when we are building any regional scale or the provincial scale or statewide scale travel demand model, there is always two sides of the things that we have to consider. One is that at which level, at which aggregation or disaggregated level we'll be modeling the travel behavior or travel demand, and at which scale we'll be simulating the network kind of the results or network resolution. What would be the network resolution? And the model today I will be talking about, it's in terms of the travel demand or travel behavior. You can see here, it's a micro simulation model where you micro simulate the travel behavior activity pattern of the synthetic households, farms, and how persons. And then in the network level kind of the resolution, so it's a macro model. And also similar kind of the ways goes on, what kind of the details you will go inside the modeling process. When you're building the metropolitan or regional scale model, versus the provincial model. How do you deal with the different types of the modes? For instance, when it comes to the provincial model, then basically some of the very local kind of the, for instance, like the transit especially, modes are a little bit more averaged. And then we also try to basically take into account the long distance travel, high speed rail or intercity kind of the connections, and stoppage gets more kind of the priority. And that's how kind of like provincial model or statewide model lands in. And now there are could be like questions of like, why do we need statewide model basically when you have a metropolitan model or urban kind of the model or regional scale model? So provincial like model or like statewide model basically you need because the urban models, they cannot basically forecast the intercity travels that is happening in our network. They cannot travel precisely the long distance kind of the passenger travel, long distance truck travel or like freight side. And also there are other kind of the basically like things also when you are doing policies, statewide level policies or like province-wide level policies government is making, how you can analyze those policy results. If you don't have a statewide model or province-wide model, then it would be difficult to analyze those such kind of the policy interventions. And for though all those kind of the inspirations, so this TRESO model has been built, and it's a long journey that took place between 2014 to 17 to build this model. And since 2018 it's now operation, it's in operation, and we are still working on like enhancing and improving the model. And this is it's a provincial like multimodal model that integrates the freight and passenger together. And it also have spatial macroeconomic model, which is the outside the full TRESO kind of the model. I will show you in detail in the next slides, which like forecasts or like which gives you the land use kind of the inputs, with then you feed into the TRESO model. And it also basically it's first of its kind in Canada right now, and it is sensitive to the policy changes or to the economic changes or even to the if when I will be touching base on the more choice kind of the side, it is also sensible to take into account the autonomous vehicle or even the vehicle ownership kind of the side, how it will be changing over the years. And to give a brief summary of the TRESO model itself, so it's first of all, like in our team, like we do collect the data. And as I was mentioning that about like TTS data earlier when we started our, before we started our talk, that Transportation Tomorrow Survey. So Transportation Tomorrow Survey is one of the biggest survey, or it's the biggest survey in Canada that we have been conducting in the Ontario for like starting from since in the 90s basically. And this survey, like we do it every 5 years, and this survey provides us the detailed travel diary kind of information of the households. And then this survey is usually used for our regional scale kind of the model development, as well as for TRESO or this provincial model development. And outside this, the extent of this survey area, we also have other surveys we take into account so that we can refine and develop the model more precisely and accurately for that geography. For instance, Ottawa Household Travel Survey is another one we take into advantage. And then also there are travel survey of residents of Canada that feeds into in our long distance travel model. And then there are also like business side, also farm location kind of the data also we feed in our model. And then basically, once we have all these data, then we establish the pattern and relationship. And then we calculate also the trip rates, frequencies, and probabilities. And also we do the destination or mode choice kind of the modules building, and then go ahead with the behavioral kind of the forecasting and then refining the parameters, and then we validate also the model. I will show also some insights on the validation kind of the side today. And also, if I overview the system itself, then it's a Python package that you can run, and it takes 48 hours kind of if you are running the model, full model. And then it also have a lot of the different modules that you can run even separately using the Jupyter notebook. And also it needs the big license. It's a ME based model, and it needs 32 size big license on like ME to run the model, because the network is such a huge network. And since the province, Ontario province, has also connection with US, so some of the we have, for instance, cross-border model where you also take into account what are the commuters coming, or like auto or trucks are traveling in between US to Canada on a given weekday, kind of that kind of the also side has also been taken care of. So that's why network is large in this model. And then also this model is space-time traffic assignment is like the one that has been chosen for this modeling purpose, because it has so many components, long distance and others. So going forward with the STTA instead of the SOLA has been preferred by the from the experts and also from the developing teams. And as I was speaking, that this TRESO model, it starts with, like as all other models, it starts with the network and also synthetic population, employment, and other data. And it has its own standalone outside the TRESO spatial macroeconomic and trade model, which forecasts the GDP, and then GDP by industry categories, and also the population and employment with the household segmentation. And then that model's output has been taken to do the population synthesis and farm synthesis. Farm synthesis forecasts where the farm's location will be, and from which location to which location trucks will be, commodity will be flowing, and how much tonnage it would be flowing. So all those has been synthesized in the farm synthesis model. And in the population synthesis, we prepare the synthetic population and household. And after this synthetic part is done, then we feed into our passenger side and also in the freight side. And in the passenger side, we have, as I was mentioning, Ontario province is such a big province, which could be divided into four main segments, like GGH area in the core, and then in the southwest side, east side, and northern side. So each of these geographies have their different types of demands and different types of patterns. So to take into account this passenger side module combines all these different models. For instance, like GGHM is for the GGH area, and then outside the GGH area, we have this TOMA model that takes into account the travel pattern of the other regions outside the GGH area. And then the whole model, again, before going to the assignment, it also combines all the output from all these separate models and put it into the total assignment. And similar goes to in the truck side. Truck side has been divided into also two modules. One is the long distance truck model, and another one is the urban truck tour model. So long distance will
Dr.
be
Daisy.
yes.
So sorry to interrupt. A quick question for the spatial microeconomic and trade model. What is the trade meaning behind it?
Okay, trade is that, like in the macroeconomic model, unlike any macroeconomic model. So our macroeconomic model also takes into account who are the trading partners of Canada and Ontario itself, right? So who are the trading partners? And we have separate trading partners, kind of the what proportion of the imports and exports will be happening and was happening in the history or in the past. And based on the trend of the earlier past, then we forecast for the future who would be the trading partners, what percentage and what value, monetary value of the GDP will be flowing from Canada to its trading partners. So that's why we call it trade model. It's in the bracket, you can say trade model. So it forecasts that for the future. And from there, we go ahead with, okay, this much trade is happening in which industry sector, and then what would be the GDP even associated with that trade. So all those things are basically forecasted in that model. Does that answer?
Thank you. Thank you.
Awesome. So as I was speaking, is that like, so there is like truck model, and also there is like passenger side model, and then all the models are then, demands are then assigned to the main network assignment. And we do, as I mentioned, that we do STTA currently, space-time assignment, when it comes to the network assignment. And then you can like take advantage of the network assignment results into like trip list you'll be getting, and you can do lots of the calculations, like you'll be getting the VKTs, VHTs, and from each link level kind of the results you will be getting, which you can then utilize for corridor kind of analysis, or like any sort of like CBA, or like cost benefit analysis for your projects. And if we go in detail about the system overview within, as I was speaking, that like the TOMA model, or like the passenger model, has been also amalgamation of multiple regions, right? So within these, for instance, like within each component, then there are more sub kind of modules that you can see here. For instance, today in this talk, I'll be covering mainly this TOMA model, which is the, I'll be talking about the passenger sides, long-term choice module, vehicle fleet synthesis that we do, and then how we are coming up with the activity pattern generation and tour generation, and following with these tour scheduler or temporal kind of the side and mode choice, and then like kind of the assignment. Whereas like we have other modules, as you can see here, we have long distance person travel. So if the trip length is less than 50 kilometers, then it's coming into the TOMA model. If it's more than 50 kilometers, people are commuting, or people are traveling for leisure purposes, more than 50 kilometers, then it's basically going inside the long distance person travel model, which we call LTPM. And then it goes, there are other modules. You can see that we have this commodity flow model, and we also have this long distance truck model. And then we also have urban truck tour model. So, and at the end, a combination of all these are together assigned into the network using the STTA. And then we get the outputs of the network assignments. And like before starting to the TOMA model, so TOMA is a state of practice and a state of art, I would say, tool-based model that takes into consideration the activity pattern, and then like goes with the tool model. And here in like I have these numbers, as you can see, that like if we look into North America, then currently like only 3 to 4 models are in practice. Tool-based models are in practice compared to activity-based model itself, or like the trip-based model. Most of the planning agencies are currently utilizing the like trip-based model, or aggregated, to some extent aggregated plus disaggregated kind of the models, when it's coming to the strategic planning, or when it's coming to model development. So today I'll be talking about this tool-based model that we are utilizing in practice for our like lots of like corridor kind of the analyses, and also for the like regional kind of the plans. And if I again deep dive into the TOMA's like overall like structure, then it would be like, as I was speaking, that we feed in the synthetic population, because this would be the urban passenger kind of the, or passenger travel it will be forecasting. So we feed in the synthetic population, including the household and the person file. And then we first we do the long-term choice modeling. And in the long-term choice, we have workplace location choice model, school location choice model. We also have the auto ownership model. And there is also a module called vehicle allocation. I'll touch base on this as well. And after this location choice is done, we move forward with the activity pattern kind of the choice modeling. And once, which we in research or in practice, we call it like CDEP. And after the CDEP has been like simulated, then we go with the activity location choice model. And once that's done, we move forward with the mode choice model. And once mode choice is done, we then go for temporarily allocating these trips or tours into the like module. And then we go to the like pre-assignment, and after that assignment. And in the pre-assignment part, basically, as I was mentioning, all other parts, all other components of the TRESO, we put together. As you can see, the names in the, for instance, in capital letters, BCM, LDPM, LDTM, UTTM. So all together, all these modules are then put together to do the traffic assignment. And as I was mentioning, that it's micro simulation based model when it's coming to the demand side or travel behavior side of the household or individuals. So we basically, when we are feeding in household records or person records, we are feeding in this way. And then basically what the like our model does is that it starts keeping it, it's just putting the, once each module you are running, it keeps adding the columns in the right hand side. It keeps adding that what activity it's doing, for how long, and from where they're starting, where they're finishing, and then which purpose, and then which mode, and departure time, what time they departed, because it's a tour based model, so it's linked with the like a start time and end time as well, and then for how long they travel. So these are this would be kind of the output that you can see once it's micro simulating the whole kind of the activity pattern and mode choices at the end of the DOMA run. So you can see like similar kind of the results like this. And if I touch base briefly on the long-term choice module, so like other modules, it starts with the activity measures or activity kind of the log sum calculations, where it takes into account the zonal kind of the side of the accessibility, as well as it takes into account the, we feed in the auto schemes and transit schemes. So there is a feedback loop in the model, that once you run the model, so it's goes up to the assignment again, it like gives the like a feedback loop into the long-term choice, again it runs. So that's how like model converges into the, after all these iterations, model converges into the final kind of the assigned trips and volumes in the network. So for that, like we feed in the activity measures, these auto schemes and also transit schemes to calculate that accessibilities. And also we have this work at home, because within our population segment, so there are also a population segment who work from home or who stay at home. So all these are taken into account in the activity pattern choice, which I will be touched with later on. And here, if someone is working, if someone is a worker, then basically either that person can work from home or that person can go outside for working home. So if it's a work at home, then there is also like will be tagged that work at home basically. And then if it's a work location is there, the person is choosing going outside for working, then basically there is a work location choice model, which you can see in the right hand side. And similarly, it goes into the school location choice. If someone is a student, then there is a separate module for the school location choice. And then there is also auto ownership component, where you like basically it's in the household, it's at the household level that you forecast the, like how many vehicles that that household will have. So you forecast that number of vehicles within that household is basically what we do in the auto ownership. And in the like I'm showing this schematic diagram of the work location choice model, where basically if someone is like worker and working outside the home, then basically there are also, we always cross check with the what are the observed
Excuse
also.
me, Dr.
Yes,
Daisy. We have a
yes,
question from the chat. I'm going to
sure.
read it to you. So a question from Chen Ying. Is there a role model applied after the long-term choices model?
If there is a, sorry,
Role model, ROLE, role model. Is there a role
role
model?
model.
Yeah. Chen Ying, or you could unmute yourself and clarify
Yes,
your question.
sure.
Hello.
Hi.
Thank you. So I want to ask, is there like a, so for long-term choice model, we know we know more information about each individual or the household, right? But for example, a person who is having a job doesn't mean on that day he gonna go do his job. So what person gonna do something, he maybe do something like entertainment activity or something else. So is there a role model applied after the long-term choice model? That's my question. Thank you.
Okay, so the work location or like a long-term location choice, basically it's trying to find out the locations for the people who are going for like work, school. These are the long-term locations that someone is aiming at. So the people who are just only the people who are going to the schools, or workers who are going to the work, or students who are going to the school, their basically kind of locations are searched and try to be like fixed here. The people who are coming back to the home and doing discretionary activities at home or outside home, that is like taken care of after the CREF that goes into the activity location choice. I'll be talking about it later on, but it's not part of the long-term choice, for instance, because long-term is basically the location choice that you are making for a long period of your time, which are could be like a work location or like a home location or school location that are not changing frequently. But the discretionary activities, that is under the activity location choice. I will be touch base on that later on. Does that answer to your question?
Yes, thank you.
Awesome. So as I was speaking that like for the workers, so we have this like module that we call like work location choice module, and it's it also have the utility term function that like computes the utilities, so that like you are not basically like selecting or giving a location that is unreasonable to the person. And also it takes back to the number of the like employment within the zone. So we have a threshold of like plus and minus to any employment you can basically through the iterations you can assign plus or minus to any activities within a zone basically. So that kind of the process checks and backs happens on, and then the this work location choice is done. It's pretty like a standard basically compared to like all other models, the way other models function. And once the long-term choices are done, then in this model we have this vehicle allocation model. Vehicle allocation model is one thing that allows this model to like be in the state of kind of the practice or the state of art, I would say, because it allows you to build the scenarios around the autonomous vehicle. It takes into account the autonomous vehicle being in our household or being in our network. So like as you can see, this is the standard classification most of the transportation professional accepts, like in the literature, is like from 1 to 5. You can see that like no automation to going forward with the full automation. And if we go with the high automation or full automation, for instance, then a lot of the things that ownership and then driving and those kind of the side will be relaxed, right? So in the base here, since we don't have any kind of the automation like this 3 to 5 level kind of the automation is not happening. So in our base year model, we don't have any automation, but going to the future, we have the option through this vehicle allocation module to allow the model to test the scenario for the future, such scenarios where there will be automation in place. I'll show a little more detail about it. Is that, for instance, this currently, like traditionally, it's all like, if it's even electric or gasoline powered, but still it's the traditional module. But going forward in the future, there could be 4 or 5th level kind of the autonomous and connected autonomous kind of vehicle that can come into our network, and we can even own the like autonomous vehicle going forward in the future. So it's a like kind of the process that is in the vehicle allocation module that allows us to basically define the scenario. If it's going forward with the like more than 50% autonomous, then you have the option to allow that in your model and test the scenario. And here in the like down graph, you can see that like in the base year, 2011 was the last kind of the TTS survey, or Transportation Tomorrow survey, done while when we were building the model. Later on, we had 2016 TTS available, but at that time of the model development, we had 2011 data. And there, as you can see, there were no like autonomous vehicle, and basically you can allow, for instance, 2021 to 31 to 41 to 51 going forward with like partial or like full autonomous vehicle. So you can allow that going forward in your like model. So it's a kind of a few scenarios that has been also tested to see how the model's vehicle allocation is working on, just to check and see that if we are aiming to test such scenarios, then whether we have the capability or not. And also the other thing I would like to also add on is the mobility service. So we have mobility service in our choice set, which I will touch base later on in the more choice module. So it also like one of the things that I think that like going forward in the future, for instance, Uber, Lyft, they will be taking more kind of the riders, and there will be more and more demand of that segment compared to right now. So which will relax again the vehicle ownership. People probably, because we are already seeing that literature is saying that among the millennials, the vehicle ownership tendency is to some extent declining. So these kind of the scenarios, like you can test using this model basically. And as I was speaking, is that like we will be how we can test these like autonomous vehicle into the model kind of. So it's an example is that like by running this module of the vehicle allocation, so you can basically define these two like two variables here, which is the percentage of the autonomous vehicle and then the AV scaling factor. So it's the PCE value basically 0.9, and this one is the percent of the autonomous vehicle, which is, for instance, like in a household, household one, for instance, if there are these 3 like cars and 25% are, for instance, autonomous vehicle. So given the observed data, then what percentage, or you can test the percentage, you can assign the percentage by yourself also. For instance, 25% will be autonomous vehicle, 35% will be like non-autonomous vehicle. So that kind of the way you can test the, for instance, the like scenario. And once we do the long-term choice, and also if we run the vehicle allocation module, then basically the model moves ahead with the coordinated daily activities pattern choice model, or tour generation model. So in the tour generation, so this graph I'm showing is basically it's what is observed in the travel survey, or like in the TTS data, what we have seen. These are the tour patterns you can see from our basically TTS data, or like travel survey shows this pattern of the tours making propensity. And you can also see that a large proportion of the, because it's a household travel survey, And you can see that there is a large proportion also who stay at home. They don't make any outside home kind of the activity. Probably the main kind of activity they like a stay at home kind of the activity is one of the thing also, like you can see. So in our model also, it allows when you are forecasting or when you are doing the modeling, so it also allows a person to select the stay at home kind of the activity pattern as well. And there are also some open loops or open tours you can see. And because this is observed data, and when it goes to the modeling, basically model usually closes the loop of the tour, because it comes back to the anchor. You start from the anchor, you end in the anchor. And if I overview the CDEP itself, then it starts with the synthetic population, goes with the activity pattern, kind of the simulation, then it goes to the mandatory tour frequency estimation, then a non-mandatory tour frequency estimation, then it goes also, we have this module at work subtour. So putting work as an anchor, so it also allows the individual to do the at work subtours. And after the at work subtours, it goes into the stop frequency. So how many stops one can make, and then goes to the daily tours kind of the generation. And this is the CDEP tour structure model. And this CDEP module is very similar to the city ramp model that Peter Borsha has developed, and it's pretty similar to that one, basically. And in this model, basically, for our purposes, or for our model, we the cutoff point for the maximum tour frequency is 5. So an individual can make up to 5 tours in a day, basically. And there are, for instance, for the mandatory tours, there are 51 terms within the utility function. And there are, for the non-mandatory, there are 57 terms. And for no travel tours, or like a stay at home kind of the pattern, so there are 63 terms within the utility function. And it takes into consideration the demographic kind of the attributes, socio-income kind of the attributes, as well as it takes into account some of the interactions variable. For instance, like if someone is a full-time worker and then student, then there is also that interaction terms are also there. Then there are also accessibility term, as I was talking about. So here also we feed in the accessibility terms into the model. And similarly, it goes into the stop frequency model, where we basically do stop frequency model for the work tours, university tours, school and escorting, shopping, and other non-mandatory tours kind of. We do this stop frequency, that how many times the stop one can stop. And as you can see that, like for the stops, even the cap is around 6, is the cap for within a tour. How many times people are stopping is cap is 6. And this is also in the state of practice model, or like in the literature, you can see that that is kind of the cap that has been used for the stop frequency. And again, it takes into consideration all these attributes and within the utility functions. And it also considers the auto-sufficiency, whether there is the sufficient auto available or not, because that will then again later on feed in into the, this has also the linkage into the mode choice kind of the side as well.
A quick question, Dr. Daisy, for the stops,
Yeah,
for example, in the walk tours, does the stop means I stop at a certain location to conduct an activity during the walk tour, like to do the grocery shopping, buy something?
Mm-hmm. Yep. So basically, the work tours is kind of like work tours will allow you that if you within from the work, if you're going to do any other kind of the activities, so it allows you to do that activity. So by using the activity location choice, so you choose where you are going, but it allows you, yeah, that kind of stops, escorting or like dropping off or picking up someone, or even the grocery, that kind of the like activities will, yeah, it will be in the work tours. Yeah.
But Dr. Daisy, a following question for example, the work tours or the shopping tours. If I do the shopping while work, or if I do the work while shopping, so how can you like distinguish which one is dominant, and then you classify them into different categories?
So yeah, so it also have the linkage with this mandatory and non-mandatory tours. So now if someone is making the mandatory tours, then the anchor is the, for instance, work or school. For instance, if a student, if someone is a student dominantly, then that person's like anchor point is the school. So mandatory tour will be tours, and within the tours, if there are stops you are making, then basically that will fall into the mandatory tours. Now, when it comes to the question you were asking, that how to know that which stop is dominant, right? So basically that kind of consideration has been taken in the non-mandatory tours. In other words, discretionary kind of the tours. So like shopping, for instance, if you like from home, you start a journey from home and you went to the shopping, you meet with the friends and you went to the movie, and then probably you came back home. So now in this journey, the longest time you spent on the which purpose you spend the longest time will be the your choice of the non-mandatory or type of your non-mandatory tour you are making. And others will be, for instance, shopping, you spend the highest time in this tour, from home to home tour, you spend highest time, for instance, in the shopping. Then basically shopping will be your dominant mandatory, non-mandatory tour. And in the non-mandatory shopping tour, you are making the stops like going to the movie, and then like going to the like a movie, or like going to the restaurant. So those will be the stops of that non-mandatory tour.
I see. Yeah, thanks for answering.
Okay. No problem.
Excuse me, can I ask something?
Sure.
I think you said it, but I missed that part. How did you define mandatory and non-mandatory?
Okay. So the mandatory, any, yeah, finish. I don't see.
Yeah. I just want to know, was it like based on your own judgment that you said that this kind of tours is mandatory, or?
No.
Okay.
So basically, like what is happening? Like we are feeding this synthetic household and like population, right? As I was showing earlier. So within that synthetic file, so there are persons who are doing work, right? Who has full-time status, right? So because this is a micro simulation model, so you have all this information of, for instance, like I am working, I'm a worker. So you have that information that in a given weekday, someone who is a worker, that person will be making a work tour, right? And mandatory tours are the tours that are fixed in location and time. Usually, that's why we take, for instance, work, school, those kind of the things as the mandatory kind of the.
But like, for example, shopping, how can you say if one kind of shopping must be done at this specific location or not? Do you consider that as mandatory tour or not?
No, shopping is in the literature. If you look at, shopping is always in the discretionary act, like tours. Shopping is non-mandatory tour. Work or school is the mandatory kind of the like tours you'll be speaking.
Okay, so no,
yeah.
So it's just work and school, which is mandatory.
Work and school, exactly.
Okay.
Yeah.
Okay, thanks.
Yeah. Shopping, you can why basically this non-mandatory, and understanding this non-mandatory and mandatory definition is also very, or discretionary definition is also very important in the activity-based modeling, is because like how you think about it, like shapes up how you're modeling also. Because like for instance, this shopping, as you mentioned, that shopping you can do anytime, or like it has, you can do anytime, you can merge with your for instance work trip, or in the morning, afternoon. But work,
well, it depends what kind of shopping it is, but mostly, yeah, I agree. Yeah, but mostly, for example, if you want to buy lunch, you can't buy your lunch at night.
Yeah, so you will be buying dinner at the night, right?
Yeah, but you can't skip your lunch. If you want to buy lunch, you go and buy lunch, and you have to do it. But
Yeah.
I get your point. I agree what you say. And
Yeah,
mostly
so-
it's non-mandatory.
Yes, it's mostly
Yeah.
non-mandatory, and like if you want to even go for buying the like lunch, you usually do from you don't. Sometimes you probably are going from home to make the like eat the lunch, but usually what you do at work, we are going from work to grab the lunch, right?
Yeah,
That's the
right.
stop. That's not tour.
Yeah. Mm.
So
Yeah.
yeah, so it
That's
just
right. Yeah.
yeah. So it's a
Got
stop.
it.
You know?
Mm.
Yeah.
As long as the work is part of the tour, then it's mandatory. Okay. Yeah.
Yes. Yes.
Mm.
Can I ask
yeah.
something?
Sure.
So basically, mandatory and non-mandatory actually dividing these two different activities based on time schedules. So there are certain activities, even though if we want, we actually cannot do it in other times. Like school has a specific opening and ending time, right? And work schedule similarly, at large, we can think that they have a specific starting and ending time. So that's how are you like differentiating between mandatory and non-mandatory?
So
Because
yeah.
that I
Yeah,
remember,
sorry.
I think I saw, I attended a seminar. So basically, they divided it based on this thing, that fixed time schedule, time constraint. I mean,
So yeah, that's what I was mentioning just a few minutes ago, is that usually the mandatory tours or mandatory activity is defined based on the fixity of time and location.
yeah, exactly. That's what I understand
Yeah.
from your definition. Thank you.
Exactly. Yeah, no problem.
Hi, I have a question about the person characteristics. So, for example, the escorting and they state only female. Can you explain what does it mean?
Escorting and then the female. Oh, okay. So this one person characteristics. So this is the gender variable. So if female equals to 1, so usually like in, for instance, in our model, it's a binary variable within the model. So if it's female, the person is female, then it's equals to 1. Otherwise is 0.
So if it's a male, then there's no escorting for male gonna, happen.
No, not like that. So in the econometric model, these are the, so basically what I have done is that I have listed out the variable names. So within this, what will happen is that, for instance, let me give you an example, is that in the econometric modeling, like equations, the way it works, for instance, a binary, if you're adding a binary variable, female equals to 1, male equals to 0, it means that, for instance, the sign you are seeing, right, in the equation, if there is a plus, for instance, like if it's female, then I'm just giving for the sake of, I'm giving example for the sake of example, right? For instance, if it's a female, then they will be stopping. There is a plus sign, which means that if it's a female, then there is a more tendency that female will be making more stops in a tour. Now, if utility function shows like that, then for the male, it will be opposite. That if it's a male, then they will be making lesser trips compared to the female person. So that's how we read the results of the econometric model. It's not that the way you have been explaining that male doesn't have any inputs. It's not like that.
I get it. So male is the base, and then female has a positive effect on that.
Yes, the way
for the modeling. I get it. Okay, thank you.
No problem. Yeah. Awesome. So so it's the way basically all these components that I was talking about, the CDEP model or like tour frequency model, tour non-mandatory tour frequency model, at work sub tour or stop frequency model. So you can see that these are kind of the observations that we have utilized for building this model. And also there is the rho square. You can see without constant or with constant how it looks, and of course adding the constant, it's makes the model kind of the better. And then also the predictive accuracy, you can see. I'm just respecting the time, probably I have to run a little faster. Once you were, yeah, go ahead.
To go to 11:30.
11:30, yeah. So right now it's around 11, right? So I'm just yeah, yeah. Trying to finish the. I'll run fast a little so that we can finish it up.
Yes, thank you, Dr.
Yeah, no problem. And once you have your tour like kind of activity pattern and tour and stop, like frequencies, all these are defined, then basically you are going forward with the in the model, like the way it goes is that activity location choice. Now you have activity, now where you will go for the activity location choice. So we take into consideration the current data that we have from the TTS survey and what are the anchors. So usually like in the literature you can find, and even in our model, like the anchors are chosen like the most kind of the long-term locations or like fixed locations like home or school and work. Those are kind of the anchor points, for instance, and discretionary is another kind of the site that we also consider. And we define the from the anchor, then you are going to which location you'll be choosing. So usually like in our model, like we do this kind of that from the observed data, we kind of like come up with what would be the kind of the duration people will be traveling, or which trip length people will be traveling to engage into another activity within the same tour. So that kind of the cumulative kind of distribution we came up from the observed data, which has been then utilized into the model when we are modeling or doing the anchor location choice kind of. For instance, here, like you can see that the tour pattern in the up and down, you can see the same. But for instance, like if someone is choosing the from home, the person is going to the work, and then the person is choosing the O2 as the another location for like, for instance, let's say it's the shopping activity. If the person is choosing O2, then basically the scenario of the second scenario will generate. But if the person chooses O1 on the way back to the home, then that will be another scenario. And basically we develop this theta kind of the concept, that how far people will be moving outside their current periphery. And it's based on the travel cost, how much travel cost will be incurring if you are traveling to the O1 to engage into another activity, or if you're traveling to the O2 to engage into another activity. So that travel cost in terms of the travel time and travel cost takes into consideration to choose these anchor points also, or like activity locations also. And this is how basically around the mandatory tours or in other kind of discussion activities, we do location choices. And then also like the validation kind of the side, that how the location choices compares for each of these different tours. You can see that like the TTS is our observed data and TRESO is our model, and this is another regional scale model. As I was speaking in the beginning, we compared, and you can see that like the TRESO or like the Thomas triplet distribution has a lot more kind of the representation or well representation compared to the what we fed in or like the TTS data in terms of the activity location choice within the tour. Then once we do the activity location choice, then we move with the mode choice. And this is the another like beauty of this model, I would say, is that it has mobility service as a separate nest, which allows you to test the scenarios, as I was mentioning earlier, that for instance, autonomous vehicle also, you can like check in the V1 here, you can see that auto V1 by like changing this V1 kind of the composition in your code, you can basically test that autonomous vehicle kind of the scenario. And also it like allows you to test the Uber or taxi kind of the composition or like mode choice. And also it has the parking cost kind of the module to take into consideration the parking supply, for instance. For instance, like in our, as I was speaking, that this is a provincial model, and it also people are moving from longer distance, or like it's moving from like a further distance. So in the subway or in Go Rail, you need to have the enough parking supply to for the commuters who will be dropping their car into the subway or Go station and then hopping into the Go, or like Go is a rail basically, and also to the subway. So those kind of the considerations are also considered in the destination and kind of the parking cost model. And more detail about this like module is that like it takes into, as I was talking about the V1 here, basically right now for the base year, for instance, it would be traditional and owned. So PI or P1, it would be 100% because we are not adding any other types of the vehicle in traditional, because in 2011 Uber was not captured in the TTS data, for instance. But going forward in the 2016 and going forward, so we basically test the modules that, okay, 30% for instance in the traditional and Uber. And then you, if you want to even check it for the 2031 or 41, as I was showing in the vehicle allocation model, so you can also turn in here, turn it in here by like changing these probabilities. Then also we have toll, non-toll, like within each kind of the like a leaf also within this branch. And then if you go down, so we have this toll and also non-toll, because there are some routes that are tolled. So if you are passing by the toll road, then they're also taken into consideration, which allows one to test the scenarios with tolling in a corridor, for instance. And then also shared ride kind of the side also you can test. And then there are transit side also. It has a walk, bus, and then kiss and ride and park and ride components that you can test on and add on. And then there is also Uber kind of the side which you can test on in the model. Once you do the mode choice, then basically come to the like time slicing or temporal allocation. So TRESO model allows you to like do the assignment at the for the 24 hours. At the beginning, we were running 10 like periods per day. And as you can see here, that from 12 a.m. to 5 a.m. in the morning was considered as the deep night period. And we were running the model usually for these 10 periods earlier. But now, these days, we are running 24 hours kind of the traffic assignment or STTA to better converge the model. So it allows you to basically run the model for the 24 hours. And if you want to define even specific 5 time periods, like in our regional scale model in the GGHM, we are using currently 5 time periods only. So if you want to even define it in the 5 time periods or even 10 time periods, like since it's 24 hours, you can also time slice it as you would like. And one of the thing in tour-based temporal kind of the allocation or time slicing or time choice, we always need to remember is that like the how start and end of the tour kind of the condition, right? So if someone has a activity pattern and then there is a mandatory tour, there is non-mandatory tour. For instance, someone is making 2 tours in a day, mandatory tour and non-mandatory tour. Now, if the mandatory tour doesn't finish, because the person is following by after mandatory tour, that person is making the non-mandatory tour, for instance. So if the first tour didn't finish, you cannot start the second tour. So in the tour-based kind of the model, so this kind of conditioning is also there, which then again have some implications into when it goes to the assignment. And this is kind of the results of like in the network, when you do the assignments after all these components, running all these components and do the final assignments. This is how basically I'm just showing the provincial road here. You can see that like how probably it can look basically, and it allows you to get the VKT, VHT, as I was mentioning, speed level data, or in the network at the geographical level, like it can show you where it's congested, non-congested, and all those kind of the analyses you can do. And I will just briefly touch base on the as I was giving the more kind of the thoughts about how the model model has been developed, or like the process kind of the side. So now I will just touch base briefly on the kind of the validation kind of the side. So basically, once the TOMA kind of all the trip purposes are kind of forecasted, then basically we are then comparing it with the TTS data. And we are still refining the model in some of the kind of the contexts. So we usually do validation like by trip purpose, by trip length, like what we see in the model and what we see in the TTS or like our travel survey, what we see. And also we have another regional scale model, which is the GGH, and how it compares with that model also. So we do try to validate based on the TTS data. If there is, when it comes to the road segment itself, then we compare with the count data also to see how the model is functioning. And also trip length kind of the distribution side also, we check that, okay, for any given like mode, how far like model is forecasting the trip length distribution compared to the observed data. And then again goes back to the like the numbers that we are getting. For instance, I was talking about the trip length distribution, or like total trips made, or even the VKT, vehicle kilometer traveled we are getting. Then what are the basically numbers, and how does it compares with the count data that are available? And this is basically is kind of the validation target that our model targets at. It's based on the all the literature and also NC HRP. If you're aware that like this is how the range that we tries to allow in to validate the model in terms of the VKT or like trip distance and those kind of the margin errors. Then basically comes in like this is the whole model. And now what kind of basically scenarios probably one can do. For instance, like if you you can change the economic growth, you can change in the land use side, you can change, and then automation you can do, and you can do run the pricing kind of the scenario, road pricing you're doing, and then you run the like TOMA model, and then you can analyze those kind of scenarios. You can also do like investment decisions. For instance, you are widening some part of the highway, or you are like putting tunnel on some part of the highway, or you are putting new infrastructure in some part of the highway, or any kind of this kind of investments also you can basically which you couldn't test earlier, you can now test with this province-wide way you can do if you have a road network that is going province-wide. And then also you can do like other kind of the like scenarios also, like from intercity kind of the side of the scenarios also you can test. And also you can test if you are putting the high speed rail, those kind of scenarios also you can do test using this module combined with the whole TRESO kind of the context. And definitely it comes in like basically why do we do model and what are the applications. And in the transportation agencies, basically we would like to know how the road capacity will look like after 5 years or after 10 years. Will it be basically, will our road right now, the road that we have, the capacities we have in the road is sufficient enough to accommodate the traffic in the future? So to test such kind of the scenarios, we need such kind of the travel demand forecasting model that can tell us in the future, going forward down the road after 10 years or 20 years, what would be the demand, how many people will be moving from which location to which location, and does our infrastructure needs any kind of modification or advancements or enhancements to accommodate that movement, or is that mobility and movement? So those kind of the things you can test in, and also like basically if you want to even check right now, you want to test, for instance, you want to put tolling in a like segment, you want to test that kind of the scenarios at the province-wide level, that one provincial road completely will be tagged as like toll roads. So if you want to test that kind of scenarios, you can do that. And also, as I was mentioning, investment kind of the side also, infrastructure addition or like removal kind of the side also you can test on. And then also you can test on like if demographic changes are happening, then how that will impact. If the land use is changing in the ground, then how that can also impact your kind of the model, and then investments and the future. So you can test those kind of the side as well. And the other thing is that like travel demand forecasting, that we are trying to forecast as precisely as possible, because we want to manage the demand, or we want to build the transportation infrastructure in a way that it has the capacity to move people with ease, with mobility as much as possible. And we want to also reduce the traffic congestion in the road. And for that, basically, we do such kind of the travel demand modeling and then forecasting so that we can answer those questions when we are making the decisions, basically. And I would like to thank my team. Basically, I have been working in this team since 2019, but this model has been developed since 2014 when I was a PhD student, I believe. And there has been a lots of basically the effort went on in building this model that currently I'm using and I'm part of, basically. So our team does data collection, transportation tomorrow survey, and it also does like a truck kind of the side also truck roadside survey, which we call CVS data, which I didn't touch base. For instance, today CVS data goes into the truck modeling. That portion I was talking about is the we have modules for the truck model. So CVS data feeds into the truck model, and we also collect the cordon count data, and also we have the Statistics Canada data that we do inside our team basically, and lead those conversations and also works. And then going forward with the modeling, and also we have data visualization and data analytics kind of the side, where this TRESO model, even like you can see the dashboard has been developed, and you can see all these results in the dashboard. And when we are communicating with the consultants or the stakeholders, municipalities, then there are those kind of visualizations are also available there. And that would be it. I try to finish on time, and I would be happy to answer any questions if you may have.
Yeah, thank you, Dr. Daisy. Thanks for your excellent talk. And any question from the audience? I'm going to stop the recording currently so that.
Hi again.